Hello, and welcome back to Intro to Programming. All right, so last class, we focused on the idea of kind of using variables to make our program more flexible and using variables to allow us to loop through code and repeat it again and again and again without having to write, 100 lines of code. Instead, we write one line of code and have the program repeat it over and over and over again. And we saw that with our little lab activity, where as long as we set it up correctly, we were able to repeat the same thing over and over and over again without having to rewrite code. And we also saw that by using variables, when we changed one number, we could have hundreds of calculations change and update at the same time. So today we're going to move on to sort of the next concept in programming, which is how computers make decisions. All right, so we're going to be looking at something called an if statement. And again, we're going to use Excel to sort of ease ourselves into it. But you should have seen the if statement during Angry Birds, where it could start checking for certain conditions and only run code if those conditions were true. Right? It's going to be the same idea here. It's the same idea in almost any programming language. So it's not just an Angry Birds thing. It's not just an Excel thing. It's a programming thing. It's this idea of if statements to help us make decisions. All right. So before we do that, we're just going to start with a little warm-up / review of what we did previously, just to sort of reinforce it and make sure that we're good to go. So normally, if you were in class right now, I would ask everybody to try to calculate each student's average. All right, so tests count for 40%, quizzes count for 30%, homework counts for 20%, classwork counts for 10%. So what that would mean you'd have to do is you'd have to go through and say, all right, the test grade times this percent plus the quiz grade times this percent plus the homework grade times this percent, plus the classwork grade times this percent. So take a second and try to set up that calculation. Now, if we want to drag it down, you're going to need to make sure that you lock these boxes in place, because otherwise when you try to drag it down, these boxes are going to slide down and your calculation is going to break. So give a second, try it out, see if you can get it. Feel free to pause the video. And then when you unpause it, I'm just going to go through the explanation. All right. So I don't need to turn on that right now. All right. So if I wanted to do this, any calculation that I'm doing, I always start with an equal sign. And it looks right now like my Google spreadsheet is not connecting. So let's see if we can refresh it and if that will bring it back. Sorry about this. All right. So view, zoom, 150%. All right, so we can start with our equal sign. And we're going to click on quizzes. We're going to do multiplication. We're going to multiply it by the quiz percent, which is right here. And then to lock that in place, you can either manually type in the dollar signs, or if you hit your F4 key, it'll put it in for you automatically, plus the test grade. Again, I'm going to multiply by the test percentage and hit F4 to lock that in, plus the homework grade times 20%, and I'm going to lock that in with the F4, plus the classwork grade, and then I'm going to multiply that by this 10%, and again, lock it in with the F4. So when I hit enter, I get Sally's average. And now if I go to that bottom right corner where my mouse turns to the plus sign, left click and drag, it'll calculate all of the averages for every single student. So I've got Sally, Susie, Sam, Sean, Sage, and Sabrina's average. Lots of S's in this class. Tough break for Sean there. He didn't quite make it. All right. So next thing that I usually ask kids to do is I say calculate a class average. All right. So go through and add these all together. Divide by 6 because there's 6 people. So I could do that. I could go down here and I could say equals, and I would do a left parenthesis because I have to add them all together first, and do plus, 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 close the parentheses, divide by 6, hit enter, and get the class average of 84.66667. All right. Now, hopefully you got those answers. And this is where we're going to now break into the idea of functions, so that we can talk about if statements on the next tab. All right, so Excel has functions, or Google Sheets has functions built into the software. And these functions are essentially mini little programs that you can use to make your life easier, right? And they kind of work the same way functions work in math class. In math class, when you have a function, you pass in a value, and then that function gives you a result back. It gives you an answer back. Same idea here. We pass in information to a function, and then it gives us an answer back. So one of the functions in Google Sheets is the sum function. So I could go equals, and then type the word SUM for sum. I can do a left parenthesis, and then I can highlight everything that I want it to add together. So I can go up here, I can left click on the 90.2, I can drag down, I can hit enter, and it will add those for me without me having to go through and do one plus the other, plus the other, plus the other, plus the other. Let's pretend I wanted to count them, right? Maybe I didn't want to have to manually count them. Again, there's only 6 here, so it's easy, but if there were a whole bunch, I could go equals COUNT, left parenthesis, highlight that same area, hit enter. You can type in the right parenthesis. It'll work if you don't. Like when you hit enter, it automatically puts it in for you. And I got the 6 there. And then if I did 508 divided by the 6, you would see I'd get the same exact answer when I did the whole thing by hand. All right, so these are little like programs that are built in to Excel or Sheets that are going to make our life easier. And they work pretty much the same way. You have to start with an equal sign, then you have to use its word, the syntax, and then you usually have to highlight something and pass it in. So there's actually one, we don't even have to do sum and count. We can actually just do straight average is one of them. Do a left parenthesis. So we typed in the word average, do a left parenthesis, highlight these boxes, hit enter, and you'll see that all 3 of these gave me the same exact answer. So no matter which way you do it, you're getting the same answer. It's just by taking advantage of these built-in programs, you can make your life a little easier. All right, so that's what we're going to do. So now we're going to flip over to the Regents Diploma tab. So in your spreadsheet, I know this little, let me get rid of this so that it's out of the way. We're going to flip over to the Regents Diploma tab and talk about some more functions and then sort of introduce some programming concepts with this. So right here, I have a bunch of students, Chris, Christina, Carl, Chad, Caroline, and Catherine. And I have their scores on various Regents exams that they've taken in the high school. All right, if there's a 0, it doesn't actually mean they got a 0. It just means they haven't taken it yet. Believe me, Chad knows more history than this score lets on. Okay, so what we're going to do is we're going to write a little program that figures out which students have done enough to graduate high school. So at this point, I would usually ask everybody, what do you need to pass to get a Regents Diploma? So hopefully you know that because like you're in high school trying to get a Regents Diploma, so it's good to know what you actually need to pass. So if you don't know, let me tell you. To get a Regents Diploma, and there's exceptions to this, but this is like the most common way of getting a Regents Diploma. You have to pass the English Regents. All right, so that one is non-negotiable. You have to pass the Global Regents. You have to pass the U.S. History Regents. You have to pass 1 Math Regents. And you have to pass 1 Science Regents. So bare minimum, English, Global and U.S., 1 Math, 1 Science. All right, and again, there are exceptions to that, but that's the most common route. All right, so we're going to write a program that figures out whether or not each one of these students has earned a diploma. And like I said last class, we're going to break it into little steps, all right? Just like when we did the quadratic formula. We don't want to do everything at once because then if we make a mistake, it's hard to find that mistake. So we're going to do it one step at a time so that we can break it down. Now, the function that we're going to use at the start, the two functions that we're going to use are called and or, all right? And these are taught in logic courses, but we don't really teach logic anymore, so I'm just going to go through a brief explanation. When I say the word and, all right, like you have to do your homework and hand in a project. You have to do your homework and pass a test. You have to pick up your room and cut the grass. Most people hear that, and when they hear the word and, it means both things need to be done. Both things are required. Let's contrast that to you have to pick up your room or cut the grass. You have to hand in your homework or pass the tests. When people hear the word or, they usually think, okay, I only have to do one of those. I don't have to do both. I could do both, but they're only requiring me to do one. All right. When you use the words and or in logic, it pretty much has the same meaning. All right. If you use the word and in logic, it means that for the whole statement to be true, each individual piece has to be true. Right? So if you've got like 5 different things and you separate them all with the word and, it means all 5 things have to be true for the whole statement to be considered true. Let's contrast this to or. Right? When you use or in a logic statement, only one of the things has to be true for the whole statement to be considered true. So if I'm like, did you pass the English Regents or the Global Regents or the US Regents or a Math Regents or a Science Regents? As long as you passed one, that whole statement would be considered true. With the word and, if I say, did you pass English and Global and US and one Math and one Science, the only way that would be considered true is if every one of those individual pieces was true. All right, so what we're going to do is we're going to do ands and ors to figure out whether or not they've met the various requirements. So the first requirement we're going to check is English and history. Right? Did they meet the English history requirement? Now, if you remember what I just said, to get a Regents Diploma, you have to pass all 3 of these. Every single one of them is required. So if every single one of them is required, is that an or is that an and? Right? Hopefully right now you're all saying to your computer screen, it's an and, Mr. Vona. So we're going to type an equal sign. We're going to type the word and. We're going to do a left parenthesis. And then what we're going to do is we're going to do what are called basically logical tests. All right, we're going to do a bunch of tests. We're going to say, is this box right here greater than or equal to, so I do the greater than sign first, and then I type an equal sign, 65. I then put the next test in separated by a comma. So, comma, C2 greater than or equal to 65. Comma, E2 greater than or equal to 65. So what I'm saying is each one of these is a test that's either true or false. If I want this entire thing to be true, all 3 of these have to be true. So when I hit enter, it's going to tell me that Chris met the requirement because all 3 of those are above 65. And then if I drag this down, I'm going to get true, true, false, true, false. And if you look over here, it matches up, all right? Carl passed all 3, so he's good. Chad hasn't taken U.S. history yet, so that's why he has a false. Catherine got a 64 in English, that's why she has a false. So far, so good. All right, next we have math. All right, so math is where you have to pass one math exam. If you pass all 3, great, but you're only required to pass one of them. All right, since you're only required to pass one of them, that would be an or. All right, so we're going to go over here and we're going to do the same thing we just did, except instead of typing equals and, we're going to type equals or. We're going to do a left parenthesis, and we're going to go through them one by one and say, is it greater than or equal to 65, comma, click on the next one, is that one greater than or equal to 65, comma, click on the next one, is that greater than or equal to 65. We're going to hit enter. We're going to drag it down, and this is telling us that everyone met the math requirement. And if we do a quick scan, we can see that's correct. All right, they passed one, and all three of these kids did really well on their math Regents. So we're okay. Now I want to take a second here to say just ands and ors. This is not just an Excel thing. This is in pretty much all programming languages. We use ands and ors to try to set up these like logical tests. Now science, I want you to try this one on your own. Think about it. Is this an and or an or? And then try to write it. So pause the video, give it a chance, unpause it, and I'm going to go over it right now. All right. So science, again, you only need to pass one science. So that would be an or situation. So we've got equal or, left parenthesis. And then the only difference is this time we have 4 that we have to do. So comma, click on the next one, greater than or equal to 65, comma, click on the next one, greater than or equal to 65, comma, click on the next one, greater than or equal to 65. All right. So we hit enter, it tells us it's true, we drag it down, and you should only get one false, all right? And if we look, that matches up, all right? This person got a 64 on physics, they haven't taken the other 3, so they have not met the science requirement, but everybody else has met the requirement, so they're good to go there, all right? So now we have these different situations, all right? We have English, math, science for every student. And now we're ready to determine whether or not they have a Regents Diploma. All right, and this is where we're going to start incorporating the if statement. All right, and again, the way the if statement works in Excel is we're going to do a test, like is something true, is something above 65, et cetera, et cetera. And then we have to give it 2 options. We tell the computer what to do if the test is true, and we tell the computer what to do if the test is false. All right, and in this way, we can have the computer start to make decisions. All right, let me bring up this really quick. So basically what we do is we say, all right, if it's true, do this. If it's false, do this. All right, and this kind of goes with that sort of binary 1-0 that we are getting used to and seeing again and again when we talk about computers. So if it's true, do this. If it's false, do this. And what we can do, and what we will do on the next tab, is if we start stringing these together, we can start making more complicated decisions. So when a computer looks like it's doing something complicated, what it's actually probably doing is making lots of little yes, no, 1-0 type decisions. And by doing that over and over again, we can kind of come up with some pretty complicated results. All right, think about the game like 20 questions when you're trying to think of like trying to get somebody to guess like an object, like, is it an animal? Yes or no? Does it have 4 legs? Yes or no? Does it live in trees? Yes or no? And by answering just lots of yes, no questions, you're able to drill down to a very specific object. Same kind of general idea here. All right, by asking lots of little yes, no, true, false type questions, we can come up with some pretty complicated results, especially when we combine this with the ands and the ors that we just talked about. So going back to Excel here, we're going to basically have Excel print out a message that either says diploma or no diploma. So to do that, we're going to start with our equal sign. We're going to type the word if, and we're going to do a left parenthesis. Now, the if statement wants 3 things. It wants the test, and then it wants to know what to do if the test is true, and it wants to know what to do if the test is false. So our test is going to be, did you meet all of the requirements? Now, they have to meet all of the requirements. They have to meet the English history, they have to meet the math requirement, they have to meet the science requirement. So when somebody needs to have them all, that's an and. So we're going to go equals if, left parenthesis, then we're going to type and, left parenthesis. So you can use functions inside of functions. And then when you're dealing with trues and false, I don't have to say M2 equals true. I can just say M2 and it'll know whether that's true or false. And then I can just click on N2 and then I can just click on O2. I could write M2 equals true, N2 equals true, O2 equals true, but you don't need to. When you're dealing with logic, if it's already in terms of true or false, you can just put it in there and it'll only give me true back if all of those are true. So I'm going to close the parenthesis for my and then I'm going to do a comma. All right? And the comma brings me to the second part of my if statement. The first part was the test. Now the comma is my second part, and I'm just going to tell it what I want to say. So I'm going to just put inside of quotes the word hooray. So that means that I earned my Regents Diploma. I'm going to close my quotes, and then I'm going to hit a comma. And then this is where I type what happens if it's not true. So I'm just going to put the message, sorry, with an exclamation point, and then close my quotes, and then close my parentheses. So again, here's my test. Here's what happens if the test is true. Here's what happens if the test is false. So I can hit enter, and it says hooray because this person met all three requirements. I can drag it down, and I can see that this one's a sorry because they were missing the science requirement. This one was hooray because they had all three requirements. This one was a sorry because they were missing English history. We've got another hooray here. We've got another sorry here. All right, so again, we can use this to sort of do a test, and then based on the result of the test, have our program do one option or a different option. Right? And that's kind of the premise of the if statement. So let's go to our last tab here. We're going to do one more example together, and then we're going to talk about what you actually need to do for this activity. So the example we're going to do is down here on this grade example. And we're going to show you how you can start stringing these if statements together to basically do the sort of thing that I was talking about over on this tab. All right. So let's say I wanted my program to automatically give somebody a letter grade. So instead of me having to go through and be like, oh, 65, that's a D, 75 is a C, 85 is a B, 95 is an A, I want a program that's going to do that for me automatically. All right, so again, here's an example where we can use if statements. All right, so we're going to start with our equals if. We're going to do our left parenthesis, and we're going to say if this box right here is greater than or equal to a 90. Now again, you might be saying to yourself, why are we doing this? It's because we're going to write a program that could then work for any number. So instead of just specifically saying like, oh, 65, that's a D, we're writing a general program that can work for anything. So we're saying if E25 is greater than or equal to 90, then we're going to give the person an A. Now, if it's not greater than or equal to 90, we can't just automatically give them a B. We have to check the next situation. All right? So the way we do that is we put an if statement inside of an if statement. So I type if again, and this starts a brand new if statement. So I have my test. If it's true, I print out an A. If it's not true, I then am going to do another test. And I'm going to click back on this box and say, all right, is it greater than or equal to 80? Okay. If it is, I get a B. If it's not, then I have to do another test. I can say if this box is greater than or equal to 70, I'm going to give them a C. But if not, I'm going to do another test. I'm going to say if this box is greater than or equal to 65, then I'm going to give them a D. Otherwise, and now sometimes kids want to do another test and then they say like, all right, do we need one for less than 65? You actually don't, all right? Because if they don't have an A and they don't have a B and they don't have a C and they don't have a D, unfortunately, the last thing that's left is an F. So when you get to the end, you're kind of left between two choices. So you don't actually need another if statement, because if they didn't get a D, we already know they didn't get a C, a B, or an A. So then the only other option is an F. Now you have to be careful because we've made a lot of left parentheses. So notice how when I put this right parenthesis in, it matched up and these both highlighted. When I hit the next one, this one highlights. When I hit the next one, this one highlights. When I hit the next one, this one highlights. All right, so I've got 4 right parentheses for my 4 left parentheses. If I do another one, you're going to notice that it shows up in red, and that's because there's no matching open parentheses. So that's kind of letting you know that you accidentally put an extra one in there. So if I hit enter, it tells me that the 65 is a D. If I drag my formula down, it's going to figure out all those other ones. And again, because I did it with variables, if I change these and I change this 95 to a 25, it'll tell me that they got an F. If I change it back to a 95, it'll tell me they got 100. If I change it to 105, it'll tell me that they got an A. Sorry, not that they got 100, but they got an A. So because we used variables, these should all instantly update whenever you change those numbers. And again, because we use these if statements, it's going through and kind of doing that one by one for you. Now, one thing I will say, it's important that when you set these up, you set them up in the right order. All right, so I specifically started with, is it greater than or equal to 90? All right, it's important the order you set them up in, because what if I had said greater than or equal to 65? All right, well, if I had done greater than or equal to 65, let me get the brush here. All right, and I had said, oh, are you greater than or equal to 60? Isn't this great penmanship? 65. If somebody had a 95, it would have been true, and then I never would have done sort of the other tests. So I wouldn't have known, did they have like a D or a B or a C or an A or what have you. So generally, when you're doing these if statements one after another, you start with the hardest one first. So the hardest grade to get is an A. So we start with the most specific one, and then we sort of get more general as we go. Because in this case, if you're not greater than a 65, then we know that you get the F. So false F, same thing. But if it's true, then we would have had to do a whole bunch of more tests in this direction, because just because they were above a 65 doesn't actually tell us anything. Right? It tells us that they didn't get an F, but then it doesn't tell us whether they got a D, a C, a B, or an A. Versus when we start with, are you greater than or equal to 95? Sorry, 90, then we instantly know that if that's true, you got an A. All right, so it gives us a little more information to sort of start with the specific and work to the more general. We could have done it the other way. There is a way to do it the other way. But generally, I think it's more intuitive to start with sort of the most exclusive or the hardest one, or the most specific one, and then get more general as you go. All right, so with that, you now have enough information to work on the day's activity. So what you're going to be doing is you're going to be writing some formulas. All right, anything that's highlighted in yellow, you are eventually going to be putting a formula. Now, if you do it correctly, you should only have to put a formula here, which you can then drag down. You can put a formula here, which you'll then drag down. And then you do have to put a separate formula here, here, and here. So if you do it correctly, you should only have to write 1, 2, 3, 4, 5 formulas. All right. If you don't set them up correctly, then you might have to write this one 5 separate times. But hopefully you're going to set it up correctly so that you only have to write it once and then you can drag it down. Same thing over here. You're only going to want to write it once and then drag it down. Now, let me show you what the finished product is going to look like. All right. The finished product is going to look like this. It's kind of like, think about like a grocery store. When you buy like produce, every piece of produce has like a special code. It's like the PLU number. And when you check out, the cashier will type in that number and then it will tell you like the price of that item. So like apples have a PLU, bananas have a PLU, carrots have a PLU. So this is like a very simple, like almost grocery store cash register program. So the way that it works is in the spreadsheet, when you type in a number, I type in the number 3, you want this to instantly fill in with the product and the price. Right? So if I type in a 1, it fills in with apples. If I change it to a 2, it changes it to bananas. Put a 1 here, dates. 4 here, dates again. If I type in a 7, it says error. If I leave it blank, it says error because that's a number that doesn't actually exist. All right. In our little fake grocery store, we only have 4 products. So the only numbers that should work are 1 through 4. If I type anything else in one of these boxes, it should say error. So A, error. 0, error. 56, error. 3, carrots. All right. So if I type in a 1, 2, 3, or 4, it should work. Anything else, it should say error. Now, the rest of this is just going through and adding up all of these boxes. All right. So it's using that sum function that we talked about on the first tab. So this is where you'd want to use the sum function. This is just calculating the tax. So that's just multiplication. It's doing this number times 0.08. And then this total is just adding these 2 boxes together. All right. So these are just kind of like review from what we did last class. The part that's going to be new that kind of builds on what we did today is you setting up the formulas that go here and here because they're basically going to be giant if statements. If we go back to this page here with the instructions, it says write a formula using if statements. If the order number equals 1, it should display apples. If the order number equals 2, it should display bananas. If the order number equals 3, it should display carrots. 4, dates. Anything else, it should display error. So what you're going to do is you're going to set up an if statement inside of this box. And it's basically going to be if this box equals 1, show apples. If this box equals 2, show bananas. If this box equals 3, show carrots. If this box equals 4, show dates. And I give you sort of the starting bit right here. All right, so if you look right here, it kind of says, it gives you some hints there of how you want to get started. So if B8 equals 1, you want to display G8. All right, when you just put G8 in there, just like this, that'll just make it display what's ever inside of that box, comma, if B9 equals not 1, that's a typo, if B9 equals 2, then you want to display bananas, and then so on and so forth. Now, notice that I'm using the box here instead of typing the word apples. Again, that's the idea of you always want to use variables instead of hard coding in the word apples. Because if I change my grocery store and instead of selling carrots, I want to sell, what's a good C word here? See, the word I want to type is cauliflower, but I'm not exactly 100% sure how to spell cauliflower. So then it's embarrassing if I misspell it on the internet for everyone to see. But if I change it, then it automatically changes over here. And if I change it back, it automatically changes back. So again, instead of hard coding in the word carrots, you do want to take advantage of variables just like we did last class to make sure that your program is as flexible as possible. All right, so that's the goal for today. All right, you're trying to write this program so that it will automatically fill in the meal, and then it'll automatically fill in the cost. All right, so you're going to write one formula here that displays this box, and then you're going to write a separate formula here that displays this box, or depending on what they type in, this box, or this box. And then there's no if statements for these bottom three. These are just like what we did the first day, where you're just doing some calculations. You can take advantage of the sum function here. That will make your life easier. And then the next two, you're just doing calculations. All right, this one you're doing 0.08 times the subtotal. This one you're doing tax plus the subtotal. All right, so good luck. I hope it goes well. Again, if you don't finish it by the end of the time, you don't have to do it for homework. You can try to finish it next class. It's just you want to make sure things don't pile up. So if you didn't finish the previous one and then you're not finishing this one, it can start to back up, and then you do have to get caught up and do it on your own time. But if you've just got like a little bit left, you can usually finish it up the next class. All right. Hope this was helpful. Good luck, and I will see you when I see you. All right. Bye.